Decision trees. Decision trees are a versatile supervised learning algorithm used for both classification and regression. They work by recursively splitting the data into subsets based on the feature that provides the most information gain. Each node represents a decision based on a feature, and each leaf node represents a prediction. Let's go line by line breakdown of the code for implementing a decision tree classifier in Python. I have already created the basic file. I'm going to run through the first few commands, which is first import the necessary libraries. Now for this, we are going to call from sklearn.tree import decision tree classifier, which imports the decision tree classifier class from scikit-learn's tree module. This class is used to create a decision tree model, which makes predictions by learning simple decision rules from data features. Next, from sklearn.model selection, import train test split. This imports the train test split function, which is used to split the dataset into training and testing sets. This allows the model to be trained on one subset of the data and evaluated on another. Next, from sklearn.metrics, import accuracy score and confusion metrics. This imports accuracy score to measure the model's prediction accuracy and confusion matrix to evaluate performance by counting the correct and incorrect predictions for each class. Import numpy as np. This imports the numpy library, a popular package for numerical operations and array manipulation in Python. Let's get to sample data. The sample data is again same as before, hours studied and grades versus pass fail. So I'm going to create an X array, which is np.array, which defines the feature data X as numpy array, where each element contains two values. The first value represents hours studied by a student. The second value represents prior grades. Example, the percentage. The shape of X is 10, 2, indicating 10 example rows with two feature columns. Next, y equal to np array, which defines the target data y as numpy array containing binary outcomes. 0 represents fail and 1 represents pass. This is a binary classification task which is ideal for a decision tree classifier. Next step, let's split the data into training and testing sets. We call xtrain, xtest, ytrain, ytest, and call the train test split function, which splits the data into training and testing sets. Now, xtrain and ytrain used to train the model, whereas xtest and ytest is used to evaluate the model's performance. The test size is 0.2, specifies that 20% of the data should be used for testing and the remaining 80% should be used for training. The random state is 42, which sets a seed for reproducibility, ensuring that each time the code is run, the data split is the same. Next, let's go and initialize and train the model. First, model equal to decision tree classifier. This initializes a decision tree classifier model. By default, the classifier will split data based on the Gini impurity metric to decide the best splits at each node. Other splitting criteria such as entropy are available, but this is what we're going to use right now. Next, model.fit xtrain ytrain trains the decision tree model on the training data x underscore train and y underscore train. During this process, the model learns the relationship between features, hours studied, and grades, and the target variable pass fail, building a tree structure with decision nodes that allows it to classify the new data. Next, let's go ahead and make predictions. Ypred equal to model.predict xtest. This uses the trained decision tree model to make predictions on the test set xtest. For each data point in xtest, the model predicts either 0 for fail or 1 for pass based on the decision rules it learned during training. Next, let's go ahead and evaluate the model based on accuracy score ytest ypred, which calculates the accuracy of the model by comparing the actual values ytest to the predicted values ypred. Accuracy is the ratio of correctly predicted instances to the total instances in the test set. Next, we're going to get the confusion matrix by calling the confusion matrix function, which computes the confusion matrix for the model, which provides a detailed view of the model's classification performance. We have true positives, which correctly predicted passes. We have true negatives, with correctly predicted fails, false positives with incorrectly predicted passes, and false negative shows incorrectly predicted fails. Now, next is to print the accuracy and the confusion metrics to us to show us how it looks like. Now, this code provides a complete workflow for training and evaluating a decision tree classifier on data representing hours studied and prior grades. The decision tree model predicts whether a student will pass or fail based on the input data, and the evaluation metrics, which are accuracy and confusion metrics, provide insights into its performance. Let's go ahead and run this code. Let's say Python decision tree. And there you go. We have the accuracy and the confusion metrics for this. So that's perfect. And I hope you were able to follow along and build this application. If not, let me know if you had any issues or any problems or any want to tell me something about the project. Go ahead and leave them in the comments and I'll get back to you.